the blanks here for you guys. You can thank me later when we get there. So we've got our angles. Your included side would be the side directly between the two angles. If I were to highlight each angle individually, notice that the included side is the same side that both angles share, right? Okay. All right, so what does angle side angle congruence postulate tell us? It says if two, it's your first blank, if two angles and an included side of one triangle are congruent to two angles and an included side of a second triangle, then the triangles are congruent. Okay, so let's put markings down there on that those triangles to see what that would look like. So if I did a single arc in that top left angle, single arc in that top left angle, and then a double arc in the top right, double arc in the top right, where would the included side have to be? Top left or right? Top. Does everybody see that? So that would be your angle side angle. Okay. So do we have angle side angle in the two triangles shown below? Does everybody see it? Angle side angle. Angle side angle. So this one's a yes. So now let's write the congruence statement. I'm going to go triangle ABC is congruent to triangle. What would A match up with? N. B with M. C to L. And let's just get in the habit of putting by angle side angle congruence, because you're going to have to do that on your quiz. Because on your quiz, you're just going to have a bunch of triangles, and you have to decide between the 5 theorems of which one it is. Does everybody see the angle side angle in the second one?
No.
Where's the second angle?
Because they're vertical.
Yeah, don't we have vertical angles? Right here and right here.
Yeah.
So now you have an angle here, you have a side, and you have an angle. So it's the included side. So here we do have a yes. So triangle MNT is congruent to M. Looks like it matches up with A, N to D, T to T, by angle side angle congruence. Okay, so two angles, one side. You need to decide, is the side in between it, the two angles, or is it not? If it's not, it's instead of asa, it's as. That the way you would pronunciate it? As. Be a double A-S. I lost you guys. All right, fill in the blanks here. So if two angles and the non-included the excluded side, sure. The non-included side of one triangle are congruent to two angles, and the non-included side of another triangle, then the triangles are congruent. So let's mark that up. So if we do top single arc, if I do bottom left double arc, where would the tick mark need to go? Left, right, bottom. It could go on the bottom, could go on the right too. Is the right side not included or excluded according to Ty? Yeah, so it could be either of those two. Okay, so angle side could have the side be at either of those spots. Okay, all right, so let's see if we can recognize the two on the back. Where's the side? Your reflexive property right down the middle. So you've got an angle here at A, angle here at B. You've got your side down the middle with the reflexive property. That side is not between your A and B, right? So you have A here, you have B here. Where would the included side be? It'd be right here at AB, right? So it's not, so it is angle, angle, side. So triangle ABC is congruent to triangle, looks like A would match up with D. In this case, B matches up with C, and C matches up with B by angle, angle, side congruence. And B is just the same, except it doesn't have right angles. It's just a slanted quadrilateral instead of a rectangle. So again, we have the reflexive property happening in the middle. So we've got two angles. You got an angle here. You got an angle here. You've got a non-included side. So angle, angle, side. So yes. Triangle, if I go LMN is congruent to, L would match up with, it's like O, and then M to N to M by angle, angle, side, congruence. Okay, all right, so angle, angle, side, angle, 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 side, angle. Two angles, one side is what we need. So what's a little bit harder when we do our proofs, like when we were doing our proofs with side, angle, side, all I needed to physically see was two sets of sides shown congruent and an angle, and I knew it had to be side, angle, side. What's different here is I'm going to have two angles in one side, but I might not necessarily know right away just by looking at my statements on the left whether it's angle, side, angle, or angle, angle, side. So marking your diagram is going to be helpful for you to realize which one it should be. Are you ready? No. All right, I think I have the givens there for you, but I don't have the givens for me, so I'm going to be lazy up here myself. Given, and you are welcome to be lazy like that if you ever had a problem where you weren't given the given typed there for you. Okay, so vocabulary, what do we got? Bisects, what's being bisected, a segment or an angle?
Angle.
So if bisect, then two congruent angles. What are the two congruent angles? Perfect. So notice my vertex of this angle up there is R, which they already have it labeled for us. I guess I was being very helpful when I made this diagram. So it would be R that's split in half. So the left side is SRP. So angle SRP is congruent to the right side, which would be QRP. Do we have any other vocabulary? Nope. So I need to go where to? Reflexive property. I heard it. Is it the same or switched? It is going to be the same in this case. It's just a reflection straight across. So PR or RP, you pick. PR is congruent to PR. Reflexive. Yeah, so now we have, I'm going to highlight them here. I've got a congruent angle up there in the given. We just did another congruent angle in line 2, and we have a congruent side in line 3. So it's an angle, two angles and a side. Is that side that we picked in between the two angles or not between?
In between.
It is?
Somewhere.
It's between something, not what we want it to be. So this would be an angle, angle, side, because it's not included. So angle, angle, side, congruence. Then over on the left, we just need to rewrite that prove line that's already written there for us. So triangle SRP is congruent to triangle QRP. Okay. All right, and then the last one, we get to choose our own adventure because there's 2 or 3 ways you could potentially prove it. Let's see if we can think about all 3 of them. Everybody good? All right, I get myself set up. So, got our given. What vocab do you see? Parallel and midpoint. Where do you want to go first? Okay. So if we go if midpoint, then two congruent segments. What specific segments will it be? Yeah, so if XR, and I changed it. It originally was bisect, so I think the given still says bisect. I didn't change the given part. So if XR has M being the midpoint, then it's XR that's being split into the two congruent segments, right? So XM and then RM. So XM is congruent to RM. Okay, parallel. What do parallel lines get us? Specifically, alt-int angles, congruent. Now this is where we get to choose. Which ones do you want? Give me one set of alternate interior angles. Well, if we're going with T, the alternate interior to that would be Q. So we could do, so now this is where we've got multiple ways. So everybody just watch for a second and we can choose which path we want. I could do T and Q as my one set, but in this case I could technically do a second set. Man. Hello? Hi. Yeah, I can. You're welcome. Okay. All right. Yep, bye. Ty, you're wanted at the office. Bring all your stuff. So we could have X and R. We could have Q and T. And then I would have side two angles. So this would be an angle side, right? Or I could just do one of my alternate interiors and do my vertical. And then what theorem would I have? Angle, side. Or I could keep that vertical and do X and R, which would then give me angle, side, angle. Does everybody see all three different paths? Which one's probably the easiest?
Angle, side.
Do one of the angle, sides and ignore the vertical. Why is it easier to ignore the vertical? Then I can just ditto mark this, right? And one, I could use one letter to name all the angles instead of the vertical angles where I would have to use three letters to name these two specific vertical angles. Okay, so let's go ahead and I'm going to do Q and T first. So angle Q is congruent to angle T. And then let's do X and R. So angle X is congruent to angle R. And just ditto mark it. So now I have a congruent side, congruent set of sides, congruent set of angles, congruent set of angles. And in this case, we said it was going to be an angle side. So line 5, angle side. Rewrite your prove line. So triangle X and Q congruent to triangle R M T. Okay. So there I didn't need to use a vertical on it because I got both sets of alternate interior. Or I could have just used one and then used the vertical to get the second. Questions? All right.